In the upcoming video, I make at least two mistakes, and I left them in because I think it can be helpful to see, how to find your mistakes, how to find them, and how to fix them. And so I left those in there. And I think the first one was, so the first one was in the first problem. And just so you know, when you come to it, you say, wait a minute, why did she do that? And it was a mistake. And so on the first one, on the first problem, when I copied the problem over, I was supposed to write 3 times k plus 5 equals negative 18, but I forgot the negative. And so I worked the problem without the negative, and I got the wrong answer, and I said, why is it wrong? And I went back and fixed it. Okay, and the last mistake I made, or the second mistake I made, was on the last problem that I did. And on the last problem that I did, I was supposed to subtract 10 from both sides. And when I did that, I forgot to do the subtraction right here, and I just left it as a 2. And then when I got my answer, I said, that doesn't seem right. And I checked it, and I said, no, that's not right. And so I found the problem. So I left the mistakes in so you could see how to deal with mistakes, how you can find them and fix them. We're just going to do a few random equations, have various different aspects to them, and see if we can figure out what to do with each one. So let's start with 4x minus 7 equals 2x plus 15. So we realize we have the variable on both sides of the equation. We also have a constant term, a number, on both sides of the equation. And so we need to get the variables on one side and the numbers on the other side. Doesn't matter which you do first. I will subtract the 2x from both sides just because that's what looks good to me to do. 4x minus 2x is 2x minus 7. The 2x's cancel. I have 2x minus 7 equals 15. Then I'll add 7 to both sides to get rid of the 7. I want to do that because my goal is to get the variable by itself. Right now, I want to point something out here. So I have 2x minus 7 equals 15. Now the reason why I'm going to add the 7 to both sides first before I divide by 2 is because I can't divide by 2 yet. If I divide by 2, I have to divide everything by 2. I'd have to divide the 2x by 2, the 7 by 2, and the 15 by 2. And so I don't want to do that yet. It'll be easier for me if I take the 7 to this side first, and then I only have to divide the 2 things by 2. The other way to look at it is what's being done to the x, it's being multiplied by 2. We have to undo that. But before that, 7 is being subtracted from it, and you work from the outside. So I'll add 7 to both sides, and I get 2x equals 15 plus 7 is 22. Divide both sides by 2, and I get x equals 11, and that's my answer. And I'll get to a more normal color pen here for my next example. So for my next example, let's say I had 3 times k plus 5 equals negative 18. Let's do this 2 ways. Let's do it once by dividing by 3, and then the second time let's do it with the distributive property. So we'll divide by 3. And on this side we get k plus 5. We don't need the parentheses because the parentheses were just being used to show the multiplication times 3, and we're not multiplying by 3 anymore. Now k plus 5, negative 18 divided by 3 is negative 6. And then subtract 5 from both sides, and I get k equals negative 11. Now let's do it using the distributive property. 3 times k plus 5 equals negative 18. Distribute the 3, and I get 3k plus 15 equals 18. Subtract 15 from both sides, and I get 3k equals 3. Divide both sides by 3, and I get k equals 1. Did I get k equals 1 here? No, I got k equals negative 11. So let's see, what did I do wrong? This was a negative 18. Negative 18 minus 15 is negative 33. Negative 33 divided by 3 is negative 11. Negative 11. Alright, let's try one that looks hard. Let's see if it is hard. Negative 45 equals 5 times 2a over 5 plus negative 3. So we got all kinds of stuff going on here. And there's lots of different ways you can do this one. I am going to use the distributive property, and the reason why is when I distribute this 5, when I multiply the 5 times this fraction, when I multiply by 5, it'll cancel with the 5 in the denominator, and then I won't have a fraction anymore. So, and I like not having fractions. So I have negative 45, 5 times 2a over 5, the 5's cancel, and I'm left with 2a. 5 times negative 3 is negative 15, or minus 15. Now I want to get the variable by itself. So right now I have the variable on the right hand side, so I want to get it by itself, so I'm going to add 15 to both sides. And that gets me negative 30 equals 2a. Divide both sides by 2, and a equals negative 15. So how else could we have done this one? We could have started with negative 45 equals 5 times 2a over 5. I'm just going to write this as minus 3 instead of plus negative 3. I could have divided both sides by 5. This 5 cancels. I get negative 9 equals, and then rather than writing 2a over 5, I'm going to write this as 2/5 a minus 3. And I add 3 to both sides. Negative 9 plus 3 is negative 6. Negative 6 equals 2/5 a. And then to get rid of a fraction coefficient, you multiply by the reciprocal. So I'll multiply both sides by 5/2. And 5/2 times negative 6. So 5/2 times negative 6 over 1. The 2 cancels with the negative 6, and I get a negative 3. 5 times negative 3 is negative 15 equals a. And on the right hand side, the whole point of multiplying by the reciprocal is that they cancel. But regardless, a equals negative 15. And let's see, I'll do one more. Which one will I do? I'll do negative 3k. Did I already do that one? No, I only did 2. Okay, so negative 3k plus 10 equals k plus 2. Let's start by subtracting 10 from both sides. There's no rule. You could have started with any of the things on here. You could have started with the negative 3k, the 10, the k, or the 2. Doesn't matter. Since we have variables and constants on both sides, you could do it that way. So these cancel, and I get negative 3k equals k plus 2. Now it does matter. I want to get the variables by themselves, and I have the variable by itself, and I have a variable on both sides. I want to get the variable just on one side. So I'll subtract the k here, and I get minus 4k equals 2. And have not usually been getting fractions for an answer, so I'm going to check myself on this in a minute. Divide both sides by negative 4. So k equals 2 over negative 4. By the way, that negative in the denominator, that means exactly the same thing as negative 2 over 4 with the negative going with the 2. Or you can put the negative out in front. They all mean exactly the same thing. But regardless, any of them can be reduced to negative 1/2. Let me see, is that actually right? So how would I check this? So let me check and see if it's right. So my original equation was negative 3k plus 10 equals k plus 2. I want to check to see if negative 1/2 is the right answer. So I'm going to replace k with negative 1/2. So negative 3 times negative 1/2 is positive 3/2 plus 10. Yeah, this is definitely not right. So I made a mistake. So let's go back and see where my mistake is. So, oh, yeah, so it's right here. When I should have subtracted 10 from both sides, I forgot. It says the very beginning, this step right here, 2 minus 10, that's not correct. It should be negative 8, and I wrote 2. So let's do this over again. So I have negative 3k plus 10 equals k plus 2. I want to start it the same way so I can not make the same mistake I made. So negative 3k equals k. 2 minus 10 is negative 8. Now I'll subtract k from both sides. Now it's looking more correct. So negative 4k equals negative 8. Divide both sides by negative 4, and I get k equals 2. And does that work? Let's just check that. Negative 3 times 2 plus 10. Does that equal 2 plus 2? Negative 3 times 2 is negative 6 plus 10. 2 plus 2 is 4. That's 4. That's 4. Does equal. I do have the right answer.